Again, this is the homework from 34 from last night, concept 34. So this first one, if x plus 2 is a factor, what would the root be here?
2.
Negative 2. So the root is negative 2. Okay? So immediately, you should have 1, negative 9. Stop talking, please. Okay, again, it's in order. You do not have to reorder, and there's no missing terms, so there's no zeros along the top. Can somebody raise their hand, please? Just read me off their line. Julia?
1, negative 11, 30.
So then she brings this down as x squared minus 11x plus 30. Julia, continue.
It's x minus 5, x minus 6, and x plus 2.
Very good. And that's the last factor up here. You're absolutely right, and you're done. It says find the factors. It doesn't say find the roots. You could go one more step and get the roots, but this problem says find the factors. So you stop. Again, the answer is this right here. These are your other two factors and the original one you had. We don't want roots here.
What if we put the roots in our concept? Would that be helpful?
If you wrote them down, it depends on what you circled as your answer. This is your answer. If you circled that and just wrote the roots, that's fine. But if you wrote the roots as the last line, that's your answer then. You can't just put random information that's not being asked, you know?
Which one was this one?
34. Okay. The second one, I'm not going to go through it, but what did you get for factors? Somebody raise their hand for the answer here. Juliet. Final answer.
X plus 5, M plus 2.
Agree? Okay, again, you're running a positive 1 through the table. Quickly, the next two. What do you run through the table here? What goes through the table? Good, again. In this problem, you are given the root. You don't need to switch the sign anymore. If you're given the factor, you have to switch the sign. So when you run the negative 3 through, what do the other two roots come out to be?
6 and 5.
I heard 6 and negative 1. Is that agreement, everybody? How many people agree with this? Raise your hand quickly. Only 4 people agree?
Oh yeah,
Okay. This one, sure. Okay? So when you put the numbers along the top, these are the results we're going to get here. The zero remainder indicates that yes, it was a root. This is the resulting quadratic, factoring two numbers. You can't use 3 and 2 here. That's the tricky part. A lot of people try and use 3 and 2. Because 3 and 2 are 6, and 3 and 2 are also 5 in some sense, right?
Yeah.
But again, no numbers add up to negative 5 that are negative 3 and negative 2 because they don't multiply to negative 6. So we can't use that combination. So we have to try 6 and 1 in this problem. Okay, so just be careful on your roots. Again, once you get to this line, everybody, if it says find the roots and not the factors, you can type that into your calculator and use your program. Remember the program A, B, and C? Because today we're going to have to do that. Because we're not going to have things that factor. We're going to have imaginary roots or irrational roots. So today we're going to have to either use the quadratic formula or the quadratic program that we typed. Okay? Finally, the last one. It says x-intercepts. Those are the roots. So don't let this confuse you. This is one of the roots because it's the x-intercept. So do the exact same thing as the last problem. Answers. What do we got?
4 and negative 2.
4 and negative 2. Agree or disagree? I hope we do. All right. Let's take our notes from yesterday, please. Continue with those. All right, can I get a reader, please? Ooh, Trayvon. You go, Val. Split. Trayvon, start us off, please. Listen, people. Ladies. You have till 8:38. Let's go. Trayvon, read.
Running synthetic tables just means you try several values for x, one after another. Then you can table values to point u in the right direction. Instead of a minor value, y value is zero.
Again, a running table just means that we're going to keep trying different numbers on the outside as roots. And how do we know if it's a root? What does the remainder become? Zero. So we're simply going to try it, but there's a technique, and here's the technique. Again, this is what I was telling you guys that Mr. Smith came up with, okay, the running table. So you start with the number 1. So you test 1 on the outside, okay? If you get a 0, then 1 is one of the roots, and you've done most of your work already. And you can then look at the next equation. If 1 does not give you a 0, you look at the signs. If all of the signs are positive, or if all of them are negative, you've hit what's called an upper bound, which means that the roots only exist below that. It's giving you a limit. It's saying don't try numbers bigger than 1. So if you try a 1, and 1 comes out to be an upper bound, you need to try numbers less than that, so like 0, or -1, or -2, or -3, and so forth. 0 never works unless every single term has an x in it. And think about that logically. If you plug a 0 into a function, if you have a constant at the end, it's never going to go away, is it? Everything goes to 0 except that number, everything goes to 0 except that number at the end. It's still there. So you really can never try 0 in a synthetic table unless everything has an x in it. Is that clear? Now, so if 1 didn't work and you got all positives, it means you're at the upper top. So you have to try below that. So you'd actually jump to -1. If -1 doesn't work, then you go to -2, -3, you keep trying it. But there are other things you want to consider. If the signs alternate, you've hit a lower bound. Again, if you get plus, minus, plus, minus, or minus, plus, minus, plus, then you've hit a lower bound. When you hit a lower bound, what do you have to then try? Things above it. If you hit an upper bound, and then you get to the lower bound without getting a root, then there's a problem. Then it means there's no roots of the graph. It means you have like a quartic function that's floating above the x-axis. So imagine the x-axis here, and the function is floating above it. Okay? Now, the last part is to look, and look for the remainder. Remember what we said in class yesterday? It was a very big conjecture we made. If the remainder goes from negative to positive, you've passed the root. Because remember, we're positive to negative. If you have a positive y value up here, and a negative y value down here, the only way to connect them is to go through the x-axis. Here's the x-axis right here. So in order to go through that, it means you've passed the root. So, with that said, if you try the number 2, and then you try the number 3, and your sign switches, it means one of your roots is a decimal. It's between 2 and 3. And that's when it gets a little bit tricky when they're not whole numbers. And we'll talk about what to do then.
Is there
Juliet.
a simpler way to do this than going through like upper bound and lower bound?
No, once you've done this a few times, it takes like 30 seconds to do a problem. It's really easy, actually. It looks like a lot, it really does. But you'll see right away that once we try numbers, you get used to this. That's why whenever I fill out the table, I can do it so fast, because you're going to make a running table. You're going to start doing like 5 in a row. Okay? The way to check this is simple. What do? How do you check this? You graph it, and you look for the roots in your calculator. You press second calculate, hit the 0 function like we showed in the past, and it'll find the root. You give a left bound, you give a right bound, a guess, and it chooses the root. Again, that's our way of checking for now. But I want you to know this technique. Okay, it's a good technique to use. If you take the AP Calculus exam, or if you're going to calculus, or you don't really use a calculator, you're going to have to know how to do this to find roots.
So when we put in the calculator, can we go on a table and just say 45 equals 0 6?
Absolutely, you can. If you had a table there, you could do that. It's the exact same thing this is doing. Absolutely. It's a good way to check it. So if you're looking at your table, if you want to just use the table and go from 0, 1, 2, 3, you can just keep looking. But here's the thing. If you use your calculator, the calculator gives you x and y, which is like your input and the remainder. It doesn't give you all the detail in between, which is the tough part. Because if you have the detail in between like this, you can tell if you've hit an upper or lower limit, and it tells you where to search next. Okay? That's the reason you're really using it. But again, you can use your table on your calculator to verify all of your remainders. Now, let's start with an example problem. So you're not given any roots this time. Last time we were already given a root, and we were able to plug that in. So for this problem, here's what we're starting with. So please make a synthetic table to start. Start with your synthetic table. What number do I try first?
1.
1. Again, please start with 1. It's the easiest number, and it might indicate if it's a lower or upper bound. 1 kind of splits you, right? It splits you between even positive and negative numbers. 0 doesn't really split you because you can't really test 0 here. Okay? Again, the 0 is not going to work ever for a root because you don't have an x right here. You're missing the x at the end. So here we've got 1 by 1 minus 8 is negative 7. Negative 7 and 5 is negative 2. Negative 2 and 14 is 12. Do you agree? Okay, now, here's what I want you guys to do, and this is what I did in your notes if you take a look on your actual notes that are on Headline. I wrote a little note next to each thing. All that this tells me, do I see any alternating signs every time?
No.
No. I don't see all the same signs, so I got nothing there. So all this tells me is that the point 112 is on the graph.
112. Okay.
You plugged in a 1 for x and you got a 12 out for y. So that's what I want you to write there, please. Until you get to be a pro at this, I want you to write that every time. Again, this is the point 112. Yes, sir.
That's just on 2, right?
Yes, the next one too will work. Very good. Okay. Now, if 1 didn't work, you have 2 choices. You could go up to 2, or you can go down to negative 1. Again, we're not trying 0, because 0 doesn't work unless everything has an x in it. And this 14 screws us up here. So, if you go to 2, as Trayvon noticed, it is a root. Negative 1 turns out not to be a root. Doesn't matter which way you would have guessed. I'm going to go to 2 since he already gave us the answer. It's not worth our time. Okay? So let's go to 2 now. So plugging in the 2. 2 by 1 is 2. Minus 8 is negative 6. Negative 12 and 5 is negative 7. Negative 14 and 14 is 0. Okay, Ashley?
Alright, so you try 1, 2, and 3, and then negative.
No, you try 1 to start. You try 1 to start. From there, if that doesn't work, then you choose. If it's an upper bound, you have to go down. If it's a lower bound, you have to go up. If it's neither, like we have here, the signs are just random, then you choose either go up to 2 or go down to negative 1. Trayvon chose 2 and it worked, so I said, that's fine, let's do that. So here you want to write, this is a root. Now, I could sit here and keep going. I could go to the next one and then try 3 and 4. But you could also just bring down your equation like we just did. Remember how we just did this in the last section? 34 part A? That's the reason we did it. So again, here, now just factor. It's quite simple to factor. Now, if you couldn't factor, what program should you use? The quadratic one, very good. Quadratic formula or quadratic program. My factors are negative 7 and 1, very good back then. So your roots are 7 and negative 1. And your other root was 2. Those are your 3 roots for this problem. Again, 7, negative 1, and 2. Everybody see how easy this actually is?
Yeah.
Okay? That's all we're doing. Now, here's when it gets tricky. There are 2 ways for it to get tricky. One way, if you have imaginary roots, and we'll do an example of that. Another way, if you start with something like x to the 4th, because you have to make a table, and then that table is going to give you x to the 3rd, so you have to make another table. So for those examples, you're going to have like an embedded table, a table within a table. Okay, so that'll get tricky, so we'll get to that. But the basic example is right here. Again, we're looking for the roots. Let's try the next one, please. Begin the next one. It says find the x-intercepts. The x-intercepts are the roots. Try one on your own, please, in your own table here. Anthony. These are notes of you about yesterday. Yesterday we did number 1 and 2. Today we just did number 3 and 1 and number 4. Okay, just so the notes are all right about because it's longer. Yep. What's my note I should write on the right here, guys? Yeah, it's the 0.1 negative 40, but look at the signs again. What are the signs doing, guys?
Alternating.
Aren't they alternating? Look, positive,
Negative.
negative, positive, negative. Okay, so what do we call this? A lower bound, very good, or lower limit. So you try a number above then automatically. Again, everybody, whoops. My parentheses might lined up. Again, this did not work. Do not try a number less than this. Nothing will work for you there. I'm sorry, wow. Yes, do not try a number less than this. I'm sorry, I was right. Go up from here. This is a lower limit. We want to try numbers that are higher in value. So we want to try 2, 3, 4, one of those types of numbers.
He's getting so risky.
Two didn't work either, did it? Okay? God bless you, Lauren. Now, here's the thing I want you to note. If the remainder sign had changed here, you would have skipped a root. It would have been between 1 and 2. Remember, if this went from negative to positive, think about this, please. Here's what I'm going to draw for you. I'm going to draw a graph of what this looks like. 1 negative 40 is down here. 2 negative 12 is here. So we started here at 1 negative 40, and which way are we going? Up like that. Up in the positive direction, our answer. Again, because the answer is getting less negative. Less negative. So we're in the right direction. So we're going in the right direction. So we could say we're getting closer to the remainder equaling 0. That's my note to myself. I want a 0 here, don't I? I'm getting closer to 0. I'm getting closer to 0. What is it, Jay? It is 3. So this is a root. Continuing down. Julia.
You know how you're telling us to put the coordinates or whatever?
Yeah?
Do you have to do it when we find the root too?
No, I mean, it's not really that big of a deal. You should know that the root has a 0 after it. We've said it many times. If you'd like to list all the roots with zeros, that's fine. You can do that. So you could say, your roots are 3, 0, 5, 0, and 6, 0, like that. Okay? Absolutely, you could. If this is a good way to remind you that y is 0, then do that. But by now, we should all know that when we find a root, y is 0. That's the whole idea there. All right. Next one. We got 5, 6, and 7 still. Go to the next page on your paper. Is that the door or is that somebody messing around, Jason? Say again?
How can it be me? I was asleep.
Your hand was under hanging. It was probably just locked. Yeah. Try the next one, please. Let's go. Look for your missing zeros here.
Alright, we got,
I don't know.
it's a decimal, right?
Yes, that's the key. That's what we're going through here.
So, I was talking about yesterday. We did it.
Stop.
It's not me.
Either whoever's doing it, I don't care. Just stop. All right. In this problem, if you forget that 0, everybody look here, please. If you forget the 0, you're going to try 1 and it won't work. But 1 should work. 1 is one of the roots. But if you forgot that 0, you would miss it. You clear? Okay, again. Now, when I get the next thing, take a look here. Can anybody factor this?
Oh, you have to use your calculator.
You can't factor it. So either go to your quadratic formula or use your quadratic program. If you use the quadratic program and it's irrational, it will give you a decimal estimate. I'm going to put up the answer if you use the quadratic formula here.
1.5.
Okay.
Okay.
Could you factor out what? Yeah, you can factor it, guys. But that's still you can't do. But for the quadratic formula, and you're using the quadratic formula, these numbers are messy. Luis is absolutely right. Factor first. Factor out the 4 here. Again, remember we factored out the 4 like that. So you could do that and then use this one here instead. Again, if you're using the quadratic program in your calculator, it doesn't matter. Because it crunches all the numbers. But if you're doing it by hand and you have to worry about 4AC, you don't have to do 4AC now. Okay? Using the quadratic formula you get, and I'll check the answers the other way too. That's what you'll get with the quadratic formula. What do you get with the calculator, guys?
1.56 and negative 2.5.
Okay? Again, same answer. 1 is an approximation. Okay? Same answer, people. 1's an approximation, so we put approximation somewhere. Number 6.
Is this another?
Number 6 is real tricky, by the way.
1.
Zac Efron, I hear nasty Zac Efron. I do not like Zac Efron. I think he's amazing.
Yes, sure. Let others determine stuff for a minute.
He's a good actor. Why was he not I personally never seen movies either. The worst movie I've ever seen in my life is Zac Efron.
Jason, stop talking about your obsession with Zac Efron here. Start your math homework. I can hear you messing with her the whole time over there. He's laughing too. All right. Now, here's the thing I want you all to notice. Listen, please. At this point in time, either you can go up to 2 or down to -1. Now, I know one way will work and one won't. What I want to show you is this, though. This is the key here. If I try a 2 here, okay, say I went up to 2, I end up getting 1, 2, -12, -64, -153. Now, take a look here. Graph this in your mind. The point 1, -80 is here. The point 2, -153 is down here. So you are going where? You're going down. You're going further from the axis, aren't you? Don't you want to go toward the x-axis? So really, at this point, even though this is not one of my bounds, because the signs don't show that, I should then say, let me not go to 3. Because, I mean, I might loop back around, it's possible, but I don't know. I could keep going down forever. But I do know that this one should probably go back around. Okay? But again, it's just a trial and error system here. So if you tried 3 next, you'll notice 3 won't work either. Just try -1 then. Okay? And you'll see what happens there. But again, if you try 3, you'll see what happens for that. All right, now, this is where it gets tricky, guys, so please listen carefully. What degree did we start with? 4th. So when you write your equation now, this is your next equation. You can't factor that by hand. Right now, maybe. There are ways to do it called grouping. We'll learn that. Trickier ways. Now, for this problem, to do this, you need to make another table for this problem. Everybody hear me? So now below this, make your subtable. This is what I was talking about before. Make your subtable for this problem. Now, the number -1 worked. It might work again, by the way. You can have a double root. You can have a double root. So if you want to write down a step here, you start with the same number you left off with. But you never try the numbers that didn't work originally. Everybody hear me? Write that down, please. The 1 and 2 you tried earlier didn't work, right? They won't work here. If they don't work in the original, they won't work in the subtable. But if they did work in the original, they could possibly work in the subtable. Okay, again, this -1 could work. Run the number through. Okay, that didn't work. You get the point. -1, -12. Now, are your signs indicating anything?
Yeah, it's negative, so we take the number. It's an upper bound.
No, no, no. It'd have to be all negative. Here's not a negative. Again, guys, if you have them all negative or all positive, this is not negative, so it doesn't tell us anything. So we could still check next. We could go to 2, but didn't we check 2 earlier?
Yeah.
So let's go down to -2 now. Okay, we're getting closer, aren't we?
No.
I'll keep putting the numbers out, guys, if you want to just write them down. I'm really interested in you looking at the behavior. -12, -7, we're getting closer to 0. We want a remainder as 0, remember. So let's try -3. Did we try 1? Yeah, we tried 1 in the beginning. Oh, 4, sorry. We could jump to 4, but it might miss something. We might miss it at -3. I'm going to keep going number at a time. I usually go by interval values. Okay?
He doesn't want us to do it because you know the answers.
It's not.
Why are you making us do it?
Because I want you to notice this. Instead of getting closer to 0, what does it then do?
And you don't know.
It gets what? But what does it do? It gets further from 0. Let's use our terminology like we're trying here.
2 points on me.
So, let's go through this. If I'm drawing this graph, my first point here is -1, -12, right here. -1, let's make this -10, and we'll make this -1. So I'm at -1, -12 down here. The next point is at -2, -7, so it gets closer. But then the next point is at -3, -16. So my graph is going to have a little bit of like a dip in here. There's going to be some sort of a curve. Remember we've seen these kinds of curves? It's supposed to. Because if we have another root possibly over here, or maybe another root over here later, we'll see that you don't have to have a root every time you have a dip. We might only have one real root that shows up here. Okay? So here's what I have to think about. If I keep going to negatives, it might keep going further and further away. So if I go back up to positives now, you see that we left off at 2, right? So what's the next positive I should try? 3. So let's try 3 here.
Our paper doesn't extend like
Go to the next page. Is there any room in the next page? On the top of the next page, leave your room? That's where I meant for you to continue. On the top of the next page, there should be some room. So if we try 3, doesn't work. We go to 4. You don't have to go through this every time. You can practice on your own. Just read for now because we're running out of time. If we go to 4, we get...
Oh, yes.
It's getting closer. If we go to 5. There it is, at 5 actually. So here's my root. Okay, so what was my root earlier, guys? What root worked up here? -1. So we got -1 and 5 so far. So to keep a tally of our roots, we've got -1 and 5. Now, next one, please. Write your equation. There's our equation. Remember? We don't need a subtable, though, because it's quadratic. But does this factor?
No.
It does?
No.
Are you sure?
I don't know.
You want to think it does. 5 and 1 does not add up to 4 because they both got to be positive or both got to be negative. 4 and 1 doesn't work either. Those will multiply to 5. You cannot factor. Quickly, quadratic program, type it in your calculator. What do you get for the roots here? Raise your hand. Negative 2 plus I and negative 2 minus I. So your roots are here and your roots are here. So what does that mean? Here's what this means. Your graph, part of it is floating above an axis. So it might look like this. Our roots were negative 1 and 5. So the graph would probably look something like this, let's say. Was it positive? Yeah, it was. Positive leading coefficient. Here's what it would look like. There's your two roots from the ones that existed at 5 and negative 1. But why is this floating? Because they're imaginary. Just like for a quadratic. When you had imaginary roots for a quadratic, it was floating above the axis or floating below the axis. Those were imaginary roots. Same thing for this portion. It's like its own little quadratic. Okay? Thank you, Jason. Last problem quickly. Here's what I want to show you for this one. If you try a 1, as we say to start with, you get 1, 1, 2, negative 3. If you try a 2, this is what you get here. So, this is the important part. Just copy this down real quick. Look at the sign of the remainder. What happened to it? It changed. So what's between 1 and 2 then?
The root.
The root. And if you graph this one, because at this point you really can't find it by hand. If you graph this one, here's 1, here's 2. The root turns out to be around here. So your graph looks like this for this one. Just in case you're wondering. And that's the only root you have. The other two roots will be imaginary for this example. But the important part is to notice that since the remainder switch signs, there's a root between 1 and 2. It's at around 1.1. You can graph on your calculator to find it and use second calculate and use the 0 function. But again, the other two roots don't even exist. So this kind of a problem you get stuck with. Sorry. Ah, dang. That should be a 3. Thank you. It's going to change the numbers. But again, what's going to happen here is this, guys. Thank you for the correction. I appreciate it. Here, the sign will still switch. Those are the wrong numbers, but this is the correct graph on the right. That's the important part I want you to gain from this. Again, ignore the numbers. What did the numbers turn out to be, Vic? Did you get them all? Anybody got all the numbers yet for these two? 3, 4, negative 2. This is going to be 3, 6. It's going to be 6. 12 and 1 is 13. 26 and negative 5.
I feel like the math teacher takes in detail from that.
Negative 21.
Why are they both negative, though? Take a look at this tonight. Check the work for it, okay? Again, though, this graph should be correct over here. It's from GeoGebra. What you want to do this weekend for your homework is the backside. Okay? Again, flip over to the backside. That's what you're doing for homework this weekend. If you need more practice problems, email me. I can email you more practice problems if you need more.
You can write them down there.
There are more on the bottom of your notes, actually, if you look at your notes. And there's some videos to watch. Julia.
That's how I'm gonna use this, okay?
You are okay.
Yeah, thank you.
No problem.
How nice is this little stand?
It's, okay, you're subtracting triple f of x, right? Here's f of x. Are both of those positive? So if you subtract them, shouldn't they both be negative? They're both positive and we're subtracting, so make them both negative. Okay, if you need more help, you may.
What number are you doing?
But I'm saying, if somebody just didn't have that, and put the words down next, that's not correct, because that shows the last line as their answer. That's completely different.
Balancing? It is.
Pretty much, yeah. And then, like, if you're getting closer or further, it tells you one way. Michelle, could you unplug me? Thanks, Anna.
We started it, so that's
The-
why we hope to see if we have.
The thing that you notice is,
Yeah.
I don't know where your thing is though.
That's an old one.
Yeah, if you got a point like here, and to say it was like 1, -10, and the next point was like 2, -5, you're getting closer to the axis. So if the number is getting closer to 0, like we did in some of these examples,
So, yeah, enough people had issues with the homework that won't count.
oh, thank you.
As long as people got it.
Yeah, I know what
If the number is like getting, closer to 0, either less negative or less positive in a sense, so it was like 10, 9, 3, then you're getting closer to 0.
That
That's if
means you're
you're
doing it the right way.
correct. And then if you miss it,
And if it's like,
if you miss it, you're good? Talk to me a second. If you miss it, then it's in between. So, Isela, is she not in here?
she's like there. She's coming.
Okay. Trade me the pencil on her desk for that. Swap it.
Just leave it. And if it goes like all over the place, that means it's imaginary. Like an imaginary number or something.
If it goes,
Like, you know how it was getting closer to
yes,
0 with the
and then it went further from
Yeah.
0, that's the imaginary indication. Yes, that's exactly right.
If you sang it, I might be able to idea.
Sing it, man, sing it. Come on, man.
Oh, I forgot to stop recording.
Trying to read the Awakening.
Is this your seat over here? Okay. Are you waiting to talk to me?
Well, you
I
can.
woke up with like a book on my shoulder.
Sorry. I thought this was gonna finish earlier, but the recording's kind of freezing. I don't want it to screw up.
I didn't get to write.
You watched 33? Okay. Do you have to watch the other 2 still? Okay. Lunch. You're in second? No, you're in third lunch.
You gotta perfect.
Sorry.
I only got two moments. All I got.
Okay.
That's all I got.